Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Hello, viewers, subscribers, students, and future engineers. There is another problem in Engineers in Progress 9.31, particularly in clock problems. As already repeated, mentioned, inspiration problems like this will help you improve in your analysis and in your engineering preparation. So give importance to these videos and sample problems. If you want to anticipate the solution to these problems, you may do so by just looking at the focus on the problems. Do not look at the solutions first. So problem 4, what time after 1 o'clock will the minute hand and the hour hand of the clock be together for the first time? Then perpendicular for the first time. Then 3 in straight line but in opposite directions for the first time. So the technique is to draw a clock reading 1 o'clock as shown. So this is 1 o'clock. Remember that the minute hand rotates faster than the hour hand. So they are together for the first time in this position shown. So from the initial position of the minute hand to its final position, we denote that by x minutes. And from the initial position of the hour hand pointing the 1 mark to its final position, that's x over 12. That's the relationship by principle. And per mark, that is 5 minutes equivalent, 30 degrees or 5 minutes. So from the figure, x is equal to 5 plus x over 12, or the other way around is x minus x over 12 is 5 minutes. So x minus x over 12 is 5 minutes. Solving for x with your calculator, it is 5 and 5 over 11 minutes. So therefore, the time 5 over 11 times 60 to convert it to seconds. So the time is 1 o'clock, 1:05 and 27.27 o'clock. So 1 o'clock, 5, this is minutes, and this is seconds. Then second part, perpendicular for the first time. Again, we draw a clock with reading 1 o'clock as shown here. Sorry. So that's 1 o'clock and they are perpendicular. The angle between them originally is only 30 degrees. So the minute hand should overtake the hour hand first before they can form, before they are perpendicular for the first time. So it should overtake the hour hand as shown. So from initial position of the minute hand to its final position, call that x. Initial position of the hour hand to its final position, x over 12. And therefore, x is equal to 12 to 1, 5 minutes. 1 to final position of the hour hand, x over 12. Then final position of the hour hand to final position of the minute hand, since that's 90 degrees, and 90 degrees corresponds to 15 minutes. So plus 15. X therefore is 5 plus x over 12 plus 15. So x is 5 plus x over 12 plus 15. So 11 over 12x is 20. So for problems related to this, similar to this, the technique is x should always be uh, repeating non-terminating decimals because the denominator is always 11. Again, for common problems like this, x is always repeating non-terminating decimals, or it may be a whole number. It may also be a whole number, but that's rare. Most often, the answer would be repeating non-terminating decimals. So that's the guide. So in minutes, to be exact, x is 21 and 9 over 11 minutes. Then 9 over 11 minutes times 60, that would be 49.09 seconds. So therefore, the time is 1:21:49 o'clock. So you may disregard the decimal for the seconds normally. So that's for number 4.2. For 4.3, we draw another line, a clock reading 1 o'clock. Then they are on a straight line in opposite directions. So this would be the figure. So from the initial position of the minute hand to its final position, x as usual. Then initial position of the hour hand to its final position, x over 12. It should not go beyond 2 because uh, the time should always be 1 something for this problem. So and when they are on a straight line, 180 degrees divided by 30 is 6, and 6 times 5 is 30 minutes. Though the equivalent number of minutes for an angular spacing of 180 is 30 minutes. Remember that per mark, the angle is 30 degrees, and that corresponds to 5 minutes. So the equation would be x is equal to 5 plus x over 12 plus 30. This 30 here. So x is 5 plus x over 12 plus 30. So 11 over 12, x is 35. Therefore, x is 38 and 2 over 11 minutes. So the time, 2 over 11 times 60, time is 1:38, 10:91 o'clock. Problem 5. It is now 2 o'clock. After how many minutes with the hands of a clock form an angle of 45 degrees. Then together for the first time on a straight line, there are two cases. One would be they are on the same direction. The other would be when the hands of the clock are in opposite directions. So by principle, we draw a clock reading 2 o'clock first. So that's 2 o'clock. And initial angle between the hands of the clock when the time is 2 o'clock exactly is 60 degrees. And since the minute hand rotates faster than the hour hand, then this should be the position of the minute hand so that the minute hand and the hour hand will form an angle of 45 degrees. 45 degrees divided by 30 is 1.5, and 1.5 times 5 is 7.5 minutes. So 45 degrees corresponds to 7.5 minutes. Initial position of the minute hand to its final position x. Initial position of hour hand to its final position x over 12. So from the figure, x plus 7.5, then minus x over 12, it ends at 2, and 2 corresponds to 10 minutes. So x plus 7.5 minus x over 12 equals 10. 11 over 12, x is 2.5. So x is 2 and 8 over 11 minutes. So that's the answer. Then for 5.2, case 1, this should be the figure. They are opposite. They are together for the first time. Initial position of minute hand to its final position x. Initial position of the hour hand pointing the 2 mark to final position x over 12. So from the figure, x minus x over 12 is 10 minutes. It ends at 2. So x is 10 and 10 over 11 minutes to be exact. Then for case 2, this is the position of the hands of the clock. They are on the straight line but opposite in directions. Initial position of the minute hand to its final position, denote that with x. Initial position of the hour hand to its final position, this is x over 12. So from the figure, x is equal to, that's 10 minutes up to 2, then plus x over 12, then plus 30. So x equals 10 plus x over 12 plus 30. Solving for x, x is 43 and 7 over 11 minutes. Then for the last problem, it is now past 9 o'clock. The vertical line through the center bisects the angle between the hands of the clock. What time is it? So we draw a line anticipating that the time is past 9 o'clock, and since the movement of the hour hand is limited between 9 and 10, so this would be the possible, it should be more than half. It should go past the midpoint between 9 and 10, and so that this angle, this is the vertical line, so that this angle would be equal to that angle, the position of the minute hand should be somewhere here. Sorry, the hour hand should point before the midpoint, because uh, X is less than 30 minutes as shown in the figure. So if I call that theta, that's also theta. That theta corresponds to X minutes also. Then because this is the initial position of the minute hand to its final position, we denoted that with X, initial position of the hour hand to its final position, X over 12. We know that from 9 to 12, that's 15 minutes. Therefore, this theta or equivalent number of minutes here is 15 minutes minus x over 12. So we equate 15 minus x over 12 to x, and solving for x, it is equal to 13 and 11 over 13 minutes. So the time would be 9, 13, 50.77 o'clock. So that's it for this video. I hope that you were able to understand the explanations and the solutions.